Okay, good morning everyone. Up to last lecture we have covered the design procedure of Purlin up to the calculate factor load due to the combination. So from today we are going to start the step number 6. That these 5 steps we have covered. Step 1 was the calculate slope of the truss. Step 2, calculate spacing of the purlin. Step number 3, calculate gravity loads on the purlin. Step number 4 was calculate components of the load, and step 5 was the calculate factored load due to combination. So we have covered in the last lecture these many 5 steps. So step number 6 is calculate sorry calculate biaxial moments. So calculate step number 6, calculate biaxial moments. So there are while design of purlin there are two movements we have to calculate. One is in the x direction. Biaxial, it means two movements we have to calculate. One is in the x direction and another is in y direction. So first movement, that is the mx, we have to calculate in x direction. So how to calculate the movement due to in x direction? So we have to calculate movement in x direction by using the formula wy l square divided by 10, and my we have to calculate by using the formula wx l square divided by 10. So here the moment in x direction we have to calculate by using this wy load. So critical load we have find out from the step number 5. Critical load in x direction and critical load in y direction. So the y direction load we have to use while calculating the bending moment in x direction, and x direction load we have to take while calculating the bending moment in y direction. So these are the two formulas we have to use for the calculation of the biaxial moment, that is mx and my. So my and mx are the biaxial moments. So this is the step number 6. So we have to keep these formulas in mind, because sometimes in examination for MCQ purpose this formulas will be asked as a MCQ question. mx and my. So wy l square by 10. So this 10 is very important, because generally for calculation of the simply supported beam with subjected to UDL, we are using the formula for moment is the WL square by 8. So same effect is there here also, but here the purlin is a continuous beam. When simply supported beam is there and subjected to UDL, the bending moment is WL square by 8, but the purlin is a continuous member. So when we are calculating bending moment for this continuous member, the m is equal to here WL square by 10 is there. So this is very important here. The bending moment for purlin is m is equal to WL square by 10. So Wx and Wy, these are the x and y component loads. So here keep in mind why 10 is there, because this is a continuous beam. Purlin act as a continuous beam. So mx and my with x instead of 8, 10 is there. So now next step is the step number 7. So step 7 is the selection of selection of angle section. Selection of angle section. As a purlin, we have to select angle section. So how to select angle section? So the number 1, width of angle, width of angle, width of angle parallel to roof. Width of angle parallel to roof should not be less than L by 60. See, angle having two dimension, width and depth. So width of angle is parallel to roof and it should not be less than L by 60. So now here L is the spacing of truss. So similarly, we have to calculate depth of angle. So depth of angle normal to roof. Depth of angle normal to roof should not be less than L by 45. L by 45. So by using this L by 60 and L by 45, we have to calculate or find the width and depth of the angle section. So where L is equal to spacing of truss. L is equal to spacing of truss. So these two questions also many times asked in examination for MCQ. Width of angle, how to calculate? L by 60, and depth of angle L by 45. So should not be less than L by 60 is the limit for the width and L by 45 is the limit for the depth of angle. So in this way we can calculate the depth and width of the angle section. Are you getting? So, and here L is the spacing of truss, because your purlin is resting on the truss. So we are using the length as a spacing between the truss. So this is the step number 7. So next step number 8, is classify the section. So whatever selected section, angle section, we have to classify that angle section on the basis of limiting width to thickness and depth to thickness ratio. So step number 8 is classify the section on the basis of limiting width to thickness ratio and depth to thickness ratio. So now, as per our earlier procedure, we have seen in the design of beam, we have to classify the section. There are 4 classification: plastic, compact, semi-compact, and slender. So as per the 4 classification, we have to classify the section for width to thickness ratio and depth to thickness ratio. So how to calculate that? So width to thickness ratio, it means W by T is less than here 9.4, then section is your plastic. Similarly, for D by T is less than 84, then it will be the plastic. Then again same here, W by T is less than 10, it is compact. Then again W by T less than 15, it will be the semi compact. And when the W by T ratio greater than 15, it will be the slender classification. So these are the 4 classifications we have seen for flange and wave in the unit number 6, design of beam. So similarly here we have to classify the angle section for width and depth of the section, and that classifications are plastic, compact, semi-compact, and slender. So write down these classifications for angle. So similar to width and depth to thickness ratio, we have classified here angle section in various classifications. So whatever section we will select by using the step number 7. So that angle section we have to classify in the step number 8, and the classification is on the basis of width to thickness ratio and depth to thickness ratio. So here step number 8 is over. So write down, because these values are very important for uh, objective type examination. So as width to thickness ratio less than 9.4, the which section is there. So by this way you will be asked such questions in examination for MCQ purpose. So this part should be part of your notebook. So everyone please write down this. 100% MCQ question will be asked on this classification. Okay, now step number 9. Calculate plastic modulus. Calculate plastic modulus for the angle section. So as we have calculated the ZP value, plastic modulus is nothing but ZP value in the design of beam, unit number 6. So we are designing the purlin So Purlin is again flexural member. So we are designing as a beam. So the plastic modulus is required here. So how to calculate ZP for the angle? So ZP is equal to, we have to use formula Ixx divided by here Y minimum. So I by Y is nothing but Z. So here ZP is equal to, sorry, Z, here I, Y max is there instead of Y minimum. So ZP is the Ixx divided by Y max, or we are calling as a Y bottom. It means the centroidal distance from the bottom we have to take here. Y is the centroidal distance and Ixx the moment of inertia about x-axis. So in this way we can calculate the plastic modulus, that is ZP. So here Ixx divided by, how to calculate Y bottom or Y max? So D minus CYY. So how to calculate Y? Y we can calculate D minus CYY, because Cxx and CYY values we will get from the steel table. So whatever section we will select from the steel table, for that section CYY, Ixx, Iyy, that value we will get. So if CYY is known, then we can calculate the Y max or Y bottom by using this formula. It means if we draw the section like this, so this is the your depth of section. So this is the CYY and this hole is the your D. And here purlin is there. This is the truss. So on this truss, this purlin is resting in the direction of this depth. The width is horizontal and depth is vertical here. So depth is vertical. So from this bottom, this distance is CYY, because this is the centroidal distance of the angle section CYY. If we deduct this CYY from this depth, then we will get this Y max from the bottom. Okay, similarly from the ZP we have to calculate ZE. So ZP is the plastic section modulus. Now we have to calculate here ZE. So how to calculate ZE? So ZE again I by Y. So here Ixx divided by, now here Y minimum. So Y minimum is here CYY. So centroidal distance from the here top is the CYY. So in this way we can calculate the ZE value, that is the elastic section modulus. Okay, so now these are the plastic section modulus and elastic section modulus we have calculated for the angle section. Now next step number 10. So what is 10 step? So in step number 10 we have to calculate, write down, calculate design bending moment. Design bending moment. So in the step number 6 we have calculated the biaxial bending moment as per the load coming on the your purlin. So Wx and Wy, these are the two critical loads coming on the your purlin. So as per the load coming on the purlin, we have calculated the Mx and My. But now here we have to calculate design bending moment by using this ZP value. So how to calculate the design bending moment? So design bending moment in x direction, that is the mdx. So earlier we have calculated mx. So now here we have to calculate mdx, that is the design bending moment. So mdx is equal to, so beta b, we have to use formula beta b into zp into fy divided by gamma m naught, and it should be greater than mx, because design bending moment should be greater than our actual calculated bending moment. So design bending moment in x direction is over. Now design bending moment in y direction is 1.2 into ZE into Fy divided by gamma m naught, and again it should be greater than my. So this is procedure we are using as per IS 800 2007. Design of Purlin procedure is available in the IS 800 2007. So step number 10 is over. We have calculated the bending moments. These bending moments are the design bending moments mdx and mdy. So now last step, step number 10, 11. The last step, step number 11. Now we have to take check. So now check for biaxial bending. Check for biaxial bending. So how to take check for biaxial bending? So here mx divided by mdx plus my divided by mdy, it should be less than 1. See, this check should satisfy. Then our selected section is safe for the use as a Purlin. This check should be satisfied. Mx divided by mdx plus my divided by mdy, it should be, the addition of this should be less than 1. So write down here one note. So note is, if all the requirements, if all the requirements are satisfied, if all the requirements are satisfied, then selected angle is safe for the design. These of all the requirements should satisfy. So this is the procedure of design of Purlin. So okay, now we will see one example on the design of Purlin. It is over, we have written. Okay, so now write down the problem statement. So example number 1, the design of Purlin. So write down design unequal design unequal angle purlin, design unequal angle purlin for for truss truss with 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 six panel with six panel span, just minute, span of truss, write down, span of truss is 12 meter, design unequal angle purlin for truss with six panels, span of truss is 12 meter, comma, rise of truss is 3 meter, comma, spacing of truss, spacing of truss is 4 meter, full stop, full stop. Dead load is equal to 150 newton per meter square, dead load is equal to 150 newton per meter square, comma, live load is equal to 350 newton per meter square, comma, wind load is equal to 750 newton per meter square, full stop. Dead load is equal to 150 newton per meter square, live load is equal to 350 and wind load is 750 newton per meter square, full stop. apply check as per IS 800 2007, apply check as per the IS 800 2007, stop. Draw need sketch, showing typical connection, between purlin and principal rupture, purlin and principal rupture. So this is the problem statement and given data. So what data they have given? So here given data is, so we have to design the unequal angle purlin. So for that they have given number one, so number of panels they have given. So number of panels are 6 here. So your problem statement have you written. Then write down the given data. First, the number of panels are 6 given. Then span of truss is given. Span of truss. So span of truss is 12 meter is given. Then rise of truss is given, or we can calculate the rise of truss, but here rise of truss is given, that is 3 meter, or we can calculate rise of truss. So how to calculate rise of truss? So rise of truss is equal to 3 meter they have given. So or we can calculate 1/3 to 1/5 of span. Rise of truss, how we can calculate? 1/3 to 1/5 of span. In this way we can calculate rise of truss. So what is next given data? Spacing of truss is again given. So spacing of truss, 4 number. So spacing of truss is equal to 4 meter they have given, spacing of truss. Then fifth, they have given dead load. So dead load through above structure they have given, that is the how much dead load given? 150 Newton per meter square. 150 Newton per meter square dead load is given. Then how much live load is given? So live load is equal to live load is equal to so live load is 350 and wind load is 750 is given. So live load 350 Newton per meter square and wind load 750 Newton per meter square. So this is the given data. We have to design unequal angle purlin. We have to design unequal angle purlin. This is the given data.